Okay, in problems 23 to 26, a non-homogeneous linear system is given. And a non-homogeneous is a system that has this. So if this wasn't here, then this would be a homogeneous. Like this one. This one's a homogeneous. And in fact, it calls it a homogeneous. But since there's more than that, then we call it a non-homogeneous. And in each case, determine the unique critical point. Okay, so let's determine the unique critical point of this. Well, the critical points happen when the slopes are 0. So when x prime, which is a slope, is 0, then that's going to be a condition needed for a critical point to happen. And the same thing for the y. Y prime needs to be equal to 0. So negative x minus 2y plus 5. So the first thing that I'm going to do is I'm going to multiply this bottom equation by 2. And if I do that, on the left-hand side, 2 times 0, not really changing much. But here, I'm going to get a 2. And here, I'm going to get a 4. And remember to multiply every term, because you're multiplying this whole right-hand side and this whole left-hand side, so that the equation is the same. And it doesn't get altered. Now, why can I add them together? Well, because if I assume that this is true, then I'm adding the same thing to the top equation, both on the left and on the right. So that's why I can do that. And so if I add these together, 0 plus 0 is 0. 2x minus 2x, that's just going to cancel out. Here we're going to get negative y, because 3y minus 4y is just negative y. And then here we get plus 4. So now I can solve for y. I can add y to both sides of this, and I can get y is equal to 4. Okay, well now I can plug it back into one of the two. So let's say I plug it back into the bottom one. Let's do the top one because you haven't multiplied. So we get 0 is equal to 2 times x plus 3 times y, which we said is 4, minus 6. So now we get 0 is equal to 2x plus, what's 4 times 3? 12. 4 times 3 is 12 minus 6. So now we get 12 minus 6, well, that is 6. So we can say 2x plus 6. Now if I subtract 6 from both sides, what do I get? Well, I'm not going to change the equality because I did the same thing to both sides. So now I'm just going to get negative 6 is equal to 2x, which means if I divide by 2 on both sides of this, I get that x is equal to negative 3. So I get that my critical point, and I know there's only one because this is linear. So 2 equations, 2 unknowns, I get 2 solutions. The solutions for each unknown. So we're going to get that the critical point is, and I'm going to write it over here. So, and I'll make this neat. I'll put this, a divisor here. So the critical point is, we have negative 3 for our x and 4 for our y. Now, what was the second part? Well, use a numerical solver to determine the nature of the critical point in part A. So they want to know what this is, and they want a numerical solver to do that. There's other ways to do it, but I'll show you how to do it with a numerical solver. We'll get to those. And then C, investigate the relationship between x1 and the critical point 0, 0 of the homogeneous linear system. So I have a feeling that this is the shifted version of this. Now, I don't know. I don't know because I haven't really explored these things yet, so I don't know. But if I think of this, let's think of this just as a scalar equation. If I put 0 for x time is equal to a times 0, then that's my critical point, right? I'm getting 0, 0. And so, but what if I had something here like f? Well, something must happen with this f, but this equality is not true anymore. So perhaps the thing that makes it true is a shifted version of the critical point. Now, this, I'm very impressed that I said all of this because, like I said, I haven't explored this. So this is just a hypothesis. So let's just go over to part B and let's find it out together with CalcPlot. I'll see you there.